Alright, you guys, we're getting going here on GCO2. This video deals with worksheet number 1. Alright, first thing I want to do with you a little bit is talk to you about a word that you should know and a new word that you should learn. The first one is function or functions. This one you know from algebra, and it should be somewhat familiar to you. This one over here, coordinate rule or coordinate rules, is one that we're going to learn and use quite a bit in the world of geometry. The idea about today's lesson is that what we know and understand about functions should help us with coordinates. So first thing maybe to note is, what does a function look like? Here is what we would call a linear function. And we have f of x, or the function of x. In other words, the function is based off of the x variable, and it's 3x minus 5. This area here would be an area where an input of a value, and this is kind of the output of the value or function. And so as we input in one place, we get an output based off of here. Another example of a function might be a quadratic function. You would have seen these in algebra as well. Now, just to give you a heads up what this world looks like before we get to it, a coordinate rule looks something like this. A little bit different kind of notation and look to it. But this is the coordinate rule M, and it takes all points x comma y and maps them to x plus 3, add 3 to the x values, and double the y values. Or maybe coordinate rule S could map all points x comma y to maybe 1/2 the x value and 3 times the y value. So these are coordinate rules, these are functions, they have a lot in common, and that's what we're going to review and teach in this little video. So let's take a look here. The basics of working with functions. Here again is our notation f of x, 2x squared plus x when x equals 4. And again, this x value is really what we would call an input value. Our x value, our independent variable. And what we do with this is we plug it into our equation, and it would mean, this says what's the function when our input value, x value, is 4. And so we get something that looks like this. 2 times 16 plus 4, and we get f of 4 equaling 32, and 4 more is 36. Really, and this is our output level here, and you also know this to be the point 4 and 36. Now notice, here we were given the input, we plugged it in, and we got the output. We also learned that you can work backwards through this process. Notice here, they're asking us to find the input, and they've given us the output. In other words, they gave us what the function actually equals. So here we might say f of x equals 8x minus 5. We plug in 29. Notice I'm not plugging it in for x, I'm plugging it in for the entire value of the function, the output value, and then solving for x, which is -3. So again, we learned that the input value was -3, and the output value would be -29. Now, those two things should have been reviewed. Let's go back to our coordinate rule here and speak to quickly the idea that this is going to be the same kind of concept. This will be our input area, this will be our output area. Now in geometry we have different terms for that. We call this the pre-image, the thing that comes before the image, and the image. Okay? These two terms are critical geometry terms. Another thing you'll see in a minute, a way we denote the pre-image is we might call the point A the pre-image, and its image would be A prime. That's how we know who the original was and who the image was. So let's see how these are very similar to functions. So working with the coordinate rules now, again, input, output, pre-image, image. Let's try one of these. So here it says, here's the rule, and it says determine the image. So here is the pre-image. So again, here is our mapping, our coordinate rule, 3x minus 1, 5y. And basically, we plug in our pre-image of 3 and 2, and we solve for the image. And we get 9 minus 1 is 8, 5 times 2 is 10. And so, guess what? A prime, the image, is 8, and 10. The pre-image is 3 and 2, and the image is 8 and 10. Now, like the functions, sometimes we work backwards. This is the more difficult of the process that you'll be asked to do for sure. This first one is the easier one. But let's show you how this works. So here again, we're given a rule, and it's 5x plus 3, 7y. Notice they're asking for the pre-image. They want to know what came first to give us the image of 13 and 7. In other words, this turned into 13, and this turned into negative 7. So we're going to solve those two relationships. So some x value went into this thing to give you 13. What was it? Let's see. Oh, okay, it was 2. And some y value went in here to give us negative 7 as an answer. Oh, it was negative 1. So now what we learn is that our pre-image was 2 and negative 1 to give us the image of 13 and negative 7. This is the more difficult one, so I'll do one more of them before we finish the video. Here again, it's asking for the pre-image of this. So again, here is our relationship, our coordinate rule. And basically what happened is this value turned into negative 4, this value turned into 4. So we want to solve those two situations. We get x equaling negative 11 here. And here we get 2/3 y equals 4. Y equals 4 times 3 halves. In other words, 12 divided by 2 is 6. And so D, the pre-image, was negative 11 and 6. And this is our image of negative 4 and 4.